Now, if we were to sit there and have a strong basic solution where sodium hydroxide is present, what's going to happen is the hydrogen and the hydroxide are going to form water, and the sodium, which is normally a positive charge, will balance out the negative charge on the original alcohol oxygen. So you can think of it as opposite charges attracting. Consequently, we now have ionic forces, and you can think of this as being ionic forces, making it a very polar functional group. This right here is now what's called a carboxylic acid salt. So just as NaCl, sodium chloride, is a metal, non-metal, held together by opposite ionic charges. Same thing here. You have your metal, organic, non-metal, held together by opposite organic charges, as I just circled right here. So, in this little video commentary, I want to focus on naming. So, in this case right here, I want to point out a key difference in the name. So just by changing this one single atom, which I'm highlighting right here, from a hydrogen to a metal, and my favorite metals to use are either sodium, lithium, or potassium, then you change it from a acid to a acid salt. So in this case, their fancy term was sodium carboxylate. My fancy term is going to be, using my pen to write this, is going to be acid salt. You already learned how to name acids. Let's go straight to naming acid salts. Very simple. Originally, this was benzoic acid. Let me go ahead and write the original molecule just so you can see the original molecule. So the original molecule looked like this. And you had your hydrogen. So originally, it was going to be oic acid. Now what we're going to do is we're going to cut this off, and we're going to add in a sodium. The minute we do that, it's no longer oic acid. It's going to be, what is it going to be? It's going to be O8. So we change the oic acid to a O8. So in this case, it's no longer a benzoic acid, it's going to be sodium benzoate. As you may have just figured out, we need to let people know what type of metal is connected. So we place the metal name right up in front, and we make sure there's a giant space in between. So make sure there's a giant space in between. So it's sodium benzoate. There's no reason or need to put a 1 in front of sodium. It's automatically implied to be connected to the former alcohol oxygen, now a oxide ion. That's a lot of O's. So let's go ahead and practice this really quick. Oops. Let me go ahead and practice this really quick. So, let's see. Here I have my negative charge ion. Here I have a positively charged metal. So in this case, I place the metal name in front, and it would be lithium space, and then the parent in this case would be 1, 2, 3, 4, 5, 6. So in this case, it would be hexan, and I replace the oic acid with a OIT. An OIT. An OIT. Now, how do I deal with suffix functional groups, such as this alcohol right here? This right here, we'd have to go ahead and create some extra space. So, and we have to put in front, on carbon 3 it would be 3-hydroxy. Make sure there's no space here, and then make sure we write our lithium. So lithium space 3-hydroxy hexan OIT. Notice any suffixes on this parent right here, any prefixes on the parent right up here that I just underlined, it needs to be directly attached. Notice we still maintained our space right between the metal and nonmetal. Let's go ahead and do one more. Okay, this time I'll go ahead and I'll add in a chlorine. So in this case, this would be a potassium space carbon 1, 2, 3, 4, 4 chloro, 5, 6, 7, 8 octan O8. Octan O8. So let's go ahead and move on. So whenever we sat there and we added a metal, whenever we sat there and did a replacement of the hydrogen with the metal, we call this a saponification reaction. Saponification. It's actually spelled S-A-P-O-N, sapon, but you actually emphasize the U. So yes, saponification is a process of making soaps. Soaps. So how does soap work? Well, we assume that most oils and dirts on your hands are going to be nonpolar. So they're basically going to stick to the nonpolar side of this molecule. The newly made carboxylic acid salt is going to be strong ionic forces and going to be highly polar. Consequently, this side is going to stick with water. So you can think of soap as being the middleman, which bonds both to nonpolar NP oil and dirt and polar Yeah, and polar water. So that's how it helps take off oil and dirt off your hands as you rinse it in water. Here a smaller molecule, sodium propanoate. It's used as a preservative in bakery products. And then here, this acid salt treats athlete's foot. I'm not going to draw it. You can't make me either. Esters. So this is the last part of the naming scheme for this first part of the commentary. Let's go straight to a nice example right here. We talked about how we have a name like this, and I'm just going to go back to my potassium as my example. So in this case, for the acid salt, it was potassium 1, 2, 3, 4, potassium butanoate. Now, it turns out that in a process called esterification, we can go ahead and, let me change pen colors, we can go ahead and replace the potassium with a R group. The R group can be any type of alkyl or alkyl derivative. So for example, if I were to sit there and place the potassium with a CH3, I have to get rid of that lone pair right there as well as the charge, so that way it's all balanced out. 2, 4, 6, 8. There you go. This it now has a methyl group instead of a potassium. Then the brand new name is going to be methyl. Make sure you have the YL. Make sure you have a giant space in between. Butanoate. So methyl butanoate. So let me go ahead and clean up this example right here really quick. This gives me a chance to play with my eraser, my virtual eraser. I love this, by the way. Okay. There we go. So let me go back to my pen. So in this case, this would be methyl. Let me use a bigger one. So methyl butanoate. Now, if I wanted to, I could make things really tricky. I could sit there and add in, for example, a halogen. In which case, I get to do some more erasing. It would be 3-iodo butanoate. Now there is no space in between, so let me write an exaggerated O. That O has been to Wendy's too much. Okay, so 3-iodo butanoate. Make sure to have my carboxyl alkyl group branch coming off. So in this case, this would be methyl, and notice the huge space in between. If I really wanted to make things even more difficult, I could go ahead and add in a derivative atom functional group on the nice alkyl group connected to the previous alcohol. So I can go ahead and add in a Cl for chlorine. So the carbon closest to the alcohol oxygen is going to be labeled 1. So I know I'm running out of room here, so this would be a 1-chloro that should be in front, methyl 3-iodo-butanoate. So getting kind of messy now, but this now gives you insight into how we name this. In this case, we have a ethyl portion here, ethyl hexanoate. Notice the carbonyl portion here contributes to smells essentially, so this is a pineapple flavoring / fragrance. Let's go back to the name and summarize this. So the second word is a carboxylic acid name. In this case, it was propanoic acid, but it was changed to an oate. So the acid part is always at the end. The alcohol part, the OR, is always at the beginning, and you have a nice gap or space. Consequently, going to this example that I'm about to highlight with my yellow pen, ethyl, and then the rest of the parent acid is going to be benzoate. Okay, so let me give you 2 more hard ones and then we're done. So going to my regular pen, I could give you one that looks like this right here. So in this case, here I have a here I have the alcohol R group, and this right here would be a 1-chloro 1-chloro-butyl. We're going to have a giant space in between, and then we're going to go ahead and finish up the rest. So carbon 1, 2, 3, 4, 5, 6, 7, 8. So the parent would be the parent on the carbonyl side would be a octane. However, it'd be an octanoate. Keep in mind, however, we do have a common alkyl group name, T-butyl, so we didn't need a space. This would be 4-T or butyl octanoate. And go ahead and just use one more slide. And we'll do I'm adding in sound effects. I'm going to give you my hardest one possible. Now, even though we often say the parent is going to be connected to the carbonyl side, there's no reason that the R group coming off the alcohol portion is it can't be bigger. So in this case, this could be written as 1-chloro and 1, 2, 3, 4, 5 1-chloropentyl space, and then this would be a methanoate. Methanoate. Notice this can be really tricky. This is not an aldehyde because there's a carbonyl group and a previous alcohol group that is on here. So this is a classic example of a really hard carboxylic acid ester. I love this one as a bonus one. It's one of my favorites.